The big orifice?
The big orifice, roger. Understood.
So I think you got to come way closer to the vehicle because you're going to put the cable right into the vent. There we go. You can use your zoom too to help you out.
Eric, this is what you're talking about? Video,
Yeah.
please zoom in.
Yeah. I'm going to do a quick zoom to focus and then come wider again.
Roger, understood.
All right. Tell me when.
Hold that.
All right.
So see how you're angled? See how the temper was angled away from you? And that's
Yeah.
forcing you to go putting the cable into the vent. So I would come a lot closer and then get the temp probe more up and down. And then that'll keep your sensitive bits clear, and then getting a straight up and down temp probe into the vent.
Roger.
There we go. That looks a little better. You could even, yeah, that's pretty good there.
Eric, I'm frozen here.
It's hard to see in bubble, unfortunately, the bars.
Yeah.
Right, oh, well, not bad, I guess.
Yeah.
Can you move it to the left an inch?
Roger. Too far. Frozen here.
Josh, how do you feel about me coming in on Argus a little bit?
Sure. I think we could do 5 meters at 150.
Copy that. Virgin F. Gonna get 5 meters at bearing 150.
Can we go an inch away from us?
Sure. How about that?
Yeah, let's hold that for a sec. Let's do an inch more in away from us.
Okay. Yes, we'll watch the cable. Try that.
So for those of you on Nautilus Live, on the quad view, you can see those temperature measurements in the bottom left panel, together with the Hercules and Argus sonar maps. All those temperatures are in degrees Celsius.
Can we go an inch into the vent? So down?
Down into it.
Yeah.
Okay.
There we go, that's where it's hot. That
How
would be
hard are you hoping for?
not that hot.
You want me to
Alright.
pull out a little bit?
You can pull out, I know what we're doing now. Let's swap wands.
Come wide?
I'll stand by.
Okay.
Oh yeah. Come a little wide there, please.
Full wide.
Roger.
So having just checked the temperature of this vent, we're now going to just swap out the temperature probe for the...
Intake wand.
Thank you. Just while we do that, let me remind those of you watching on nautiluslive.org that Hercules and Argus are exploring the Sea Cliff hydrothermal vent sites. What you can see right in front of you with the shimmering water coming out of you is a hydrothermal vent. That water is heated as seawater seeps through the Earth's crust in the vicinity of this tectonic plate boundary, and is heated in the vicinity of hot rocks and perhaps even a magma chamber. It then becomes positively buoyant and rises up to the surface, coming out here at the site of what we call focused flow. That little chimney around it is created by the minerals dissolved in that hot water precipitating out of solution as they interact with the cold seawater at a temperature of about 2 degrees Celsius. You just saw from those temperature measurements that that water coming out of those vents is at least at 200 degrees Celsius, possibly higher. Scientists are after water that's typically less than 120 degrees Celsius for this particular measurement, mainly because that's the temperature at which the blue intake wand will start to melt.
I'm melting. Said the other one.
And these water samples we take here are going to be used for geochemical analyses. So we've moved on from the microbial tests that we were doing at the previous vent.
We'll keep you under 120 because all the other materials inside the super sample will melt around then.
That's a great point, Eric. Thank you.
We replaced that whole intake yesterday night, well, this morning.
Oh, I see. You had a couple of spares with you.
Yep.
Yeah, I hadn't noticed it yet this morning. It's all looking super shiny again.
The other thing isn't wonkily bent.
What's that?
The other probe that's taped with it. It was all bent yesterday.
Oh yeah, the Sean's thermocouple is bent.
Yeah.
When they're poking it around Octopus Gardens.
I think it was bent at the beginning of the day. I'm not sure how.
It wasn't bent at the 90 degrees.
No, it got worse.
Yeah. Yeah, we're going to point it away from us.
Yeah, no, I understand.
I think you might want to go the other way.
Yeah.
Then you're going to have to go right inside your, right, so flip it right over.
Yeah, I also think this handle might be moving a little bit.
Just come a little closer, because look and bubble. You're right out by the vent right now.
Rudder.
So you don't need to be that far away.
These hydrothermal vents are 2,700 meters below the surface of the ocean. That's where our remotely operated vehicles, Hercules and Argus, are doing the exploring for us. These voices you can hear are all in the control van of the exploration vessel Nautilus floating above all this action. We're currently positioned about 180 kilometers off the west coast of North America. pretty
Shall
much,
keep your eyes on the temperature.
pretty much off Northern California. We won't be able to show you these temperature measurements, but you'll hear the scientists reading them out to the control van. Everything's in degrees Celsius once again.
Video, you want to push in a little bit there?
Roger.
Hold that.
Is it this one? Start scanning.
Eric, what's the temperature range you're looking for?
120 and below.
120 and below, roger.
Currently at 2.
Okay.
We're gonna start at the lip of the orifice, like we did.
Bottom
with-
lip?
Yeah.
Roger.
And then you scan.
Got it.
Let's try here.
All right, we're up at 16, 20, 33. It's bouncing between the high 20s and low 30s.
I'm only getting 22.5 on Sean's. Is it like, oh, there we go. Yeah, still only get about 2.5.
Want me to push in some more?
Hold on.
Roger.
35. Yeah, going in an inch.
Okay, and I can also see if I can push towards the center of that orifice a bit more. Holding this.
The super wand is down to 4.
Yeah, it's cold. Let's go left an inch.
Stand by.
We're growing on the super wand, 20, 30s. IGT's still at 2 though.
45, 50, 62. We're gonna go off my wand.
Give me to angle it down a little bit more there, Eric. I can try to see if I can get you some more angle there.
Yeah, just a little bit more angle. We're getting about 74 right now.
It's dropping, we're in the 20s now.
Yeah, I have to slide back to the left. There we go.
We're
Want
growing
me to
again.
hold this here?
Hold it there for lock it out.
Locked out. I think it got worse.
That's, well, it's dropping. I think it might have wafted away from us. Can we go in it to inch, away from us for an inch, sorry.
Away from us for an inch, roger.
$65, 73. This should be a good first sample. Lock it out there.
It might have drifted a little bit. Want me to reset?
Yeah, we're growing, we're in the 90s. Unless you want that, Eric.
That's okay.
Is this angle okay for you, Eric?
Yeah.
100, we're growing. 106, dropping again.
Sean's is only 2 degrees. I think there's something wrong with it. Unless that's the wrong one. Is it WB7?
Oh, try W5.
Should I sleep it first or no?
No, I don't think you need to. Try sleeping it and scan again. So that means it's not communicating, so it probably is B7. If it's at that temp, it's not reading.
Well, something's wrong with it. All right, let's go off ours. 102.
We're growing again, 98.
All right, I think we're pretty stable enough that we can do it. Quit the program out. Q.
Do you guys want the flow meter?
Yeah, please. Put the bounds in. 115's good, and 0's good.
Okay. Hit enter.
Watch the temperature. If it's stable, then you can start. Tell them you're gonna start.
It's fairly stable. It's in the hundreds, between 80 and low hundreds.
Start it.
Start. Okay. All right. Starting sample now.
It's a much faster wheel spin.
You copy that, Nicole?
Copy.
Dropping to. It's wafting back and forth. That's okay. Write some notes.
How long are we sampling for here, Eric?
About 6 minutes each.
Cool, thank you.
How many bottles do you have, Eric?
8 bottles.
Roger.
What do you think our approximate distance is from the orifice?
I would say about maybe 10 centimeters at the most. Or along the lines of maybe 7.
Thank you.
So for those of you watching on Nautilus Live, we're currently using the craft Predator arm on Hercules to hold this intake wand over the vent fluid you can see coming out of that chimney in front of you. We're going to be collecting that water for at least the next 6 minutes or so. This is part of an analysis of the geochemistry of the site, trying to work out what various minerals are dissolved in that vent fluid. This whole location, the Seacliff hydrothermal vent field, is part of the Gorda Ridge plate tectonic boundary. This is a location where the Pacific and the Gorda plates meet, and as they slowly inch apart from each other, those tectonic forces cause a whole range of geological phenomena, among them these hydrothermal vents. What you're seeing is essentially seawater that seeped down through the Earth's crust in this vicinity and has come into contact with hot rocks. And they're much closer to the surface as a result of that plate boundary than they would be in any average portion of the Earth's oceanic crust. That water is then heated, it reacts with the rock chemically, and then rises buoyantly through the Earth again to come out at these chimneys, these sites of what we call focused flow. The chimneys themselves, though they look very friable and ash-like, they're actually formed by the minerals carried in that hot fluid as it precipitates out of solution on meeting, once again, cold ambient seawater at a temperature of about 2 degrees Celsius.
It's dropping a lot. It's in the 30s now. Wow, and it's 10:08.
Let me know if you need a correction.
It'll be fine. It's almost done, right? I think it's wafting
It's
back.
growing again.
You can see on the Zeus, on the Hercules Zeus camera, the big HD feed you're getting on Nautilus Live Channel 1 or Quad View top left. that the general pattern of the currents in this site are blowing uphill, if you like. You can see that shimmering vent fluid is all being directed off to the left of the screen and is rising buoyantly as it goes uphill. Occasionally though, those currents shift a little bit, and that's why the temperature we measure changes occasionally from time to time as we measure different mixing ratios of vent fluid and ambient seawater.
Can you slide it to the left, Jess?
Sure. About there?
Yeah, that's good. Thank you.
Excuse me.
Sample finished.
Oops.
Will you guys have a final flow rate and volume for that?
Yeah, one moment.
Okay.
Tell the end flow counts.
So the end flow count was 15,275. And then just that as well.
No, no. You need to do the volume.
This. 14.01 liters.
Okay.
You don't need that many significant figures.
Okay.
Just gonna steal this for 1 sec.
All right, 14 liters, and then was there a flow rate?
That's this. 2.33.
2.33 liters per minute?
Yep.
Thank you.
Then mark down your start flow counts for the next one. What else are you supposed to be doing right now?
Go home.
Yeah. Jess, can we go down 1 inch?
Down 1 inch, aye.
We're currently at 113.
Are you okay with this angle, Eric, or do you want me to change the angle too?
Angle's okay.
Roger, going down 1 inch.
Should I go to next port?
You tell me.
I assume so. I don't know if there's a reason to wait.
That was about 1 inch. Let me know if you want any more.
We're checking temperature.
Roger.
So for the script, let's change the lower bounds of the temperature to 50 degrees.
Do I have to hit enter first?
If you push up on this, it'll give you the last command.
Got it. So what did you say, 50?
50 degrees. Then we'll keep upper bounds at 115. See, we're getting like 130 right now. It's pretty hot.
Yeah.
Can you move it half an inch up?
Half inch up, aye. How about that? That might have been like 3/4 inch.
I need 1 millimeter down.
Okay, done.
It's pretty,
That's stable.
it's gone over 115 a few times.
It's okay, that's what the program's for.
Okay.
Is that 200? No.
No, no, no.
Start the sample when you're ready.
Okay.
I'm frozen here.
Starting sample now.
Could I crop in a bit on Herc while we're fixed?
Yeah, sure, go ahead.
Cool.
Pulley system going
I have
there.
to quit out of this though, right?
Yeah.
Yeah, you have to quit that first.
That's a nice close-up.
So I have to hit enter again?
Yeah, you didn't.
Okay, so actually starting sample now.
Roger.
No, you didn't put in a command. There you go.
Yeah, 1737.
Oh, you can see a fish shadow. Oh,
Yeah, an Argus cam?
yeah.
Yeah. Looks like there's a laying cat behind her, behind the predator arm. It's like a cat sprawled out. Do you see it?
Nope, nope. I'm not quite picking that one up on the
Ocean cats?
HD.
It's the new internet phenomenon.
Oh, I see it now.
It's an optical illusion.
I
Obviously,
see
it's
it.
not a cat.
Yes. No, I've got it. The little sleeping cat. It's like a little bagpuss.
A what?
Oh, what?
Ah, right. I knew I shouldn't have said that. Bagpuss was a stop-motion children's animation show in the 1970s in Britain. The Adventures of an Old Cloth Cat. And when he used to go to sleep, he looked like that.
Where is it?
Jess, I need you to reposition.
Roger.
Let's try left an inch.
Left an inch,
Oh,
Roger.
in that one. I was looking at Argus.
That's good right
I'll
there.
froze here.
It's completely there. Yeah, that's it. That's the head. That's the back, yeah. That's it. Just defocus a little bit.
I think you guys have been in here too long.
You must free your mind.
My mind's sleepy.
Evolved into cat internet, basically.
I think the more shimmery it gets in front of it, maybe, the more you can see it.
For those of you following on Nautilus Live, we've had a few days now of 24-hour operations, so
Talk about this.
you can tell things are
What is it?
starting to collapse under the strain.
Shadow.
It's something. It's a
Collapse.
dark shadow.
It's like a flying dove going from left to right.
Like a goose.
Right to left, sorry, yeah.
Goose and migration.
I don't see what you guys are talking about. I apologize.
I think I kind of see the cat now. That's
Yeah.
like the eyes here,
Yeah,
and then that's its nose, and then its little mouth.
yep.
All right. It's a big cat. It's like a lion face.
What do you think our position is now relative to last time?
That would probably be about 5
Yeah.
centimeters or so, maybe even less, maybe 4, relative to the orifice.
Bag puss.
For those of you on Nautilus Live who are wondering about these optical illusions that we're seeing in the Hercules camera, just direct your eyes to the base of the vent into which we're making the measurements, and then just scan to the right a little bit, just at the very edge of the sort of the right-hand side of the vent, that grey mottled area. That's where many experienced members of the expedition claim to see what appears to be a sleeping cat.
It's the dark gray kind of behind the shimmer. If
When-
you squint your eyes and tilt your head, you might see it.
Looks like a Pink Panther head.
Yeah.
Just want you guys to remember that this is on YouTube forever now.
My apologies. I let the cat
You're
out of the
welcome,
bag, Nicole.
YouTube. This is what YouTube wants.
Well, this is great. So researchers can later study the effect of prolonged deep sea operations on the visual acuity of ROV operators.
They start seeing cats. Make up words like bagpuss. Do you sense that indignance?
That is a real thing. It's one of those sacred childhood memories, is of
Oh.
watching shows like that. So yeah, back off video.
Bag buff.
Shots
Oh,
have
no.
been fired.
Go take over Instagram or something, or whatever you young people do.
All right, how are we doing, Eric? Let's get back on track a bit.
We're in the
What's the
70s
focus?
right
We've
now.
got 80 seconds left.
Roger.
What can we do with 80 seconds?
We count to 80.
Cats.
1, 2, 1. Back to
Going the
1.
wrong way.
Exactly.
Are these your bounds or what you actually get as your high and low?
Yeah,
Which one?
there's the set points.
Set points.
So just one more question. Is Bagpuss like the Velveteen Rabbit? Like a stuffed?
Drop it. Back away.
So John,
Just
there
walk
must
away.
be some questions from the audience about science, right? Or have we scared them all?
It's been a little bit quiet.
I wonder why.
Yep. So for those of you following on Nautilus Live, this view you're getting from Hercules is a wonderfully zoomed in view of a hydrothermal vent feature that we are currently sampling fluid from to perform geochemical analyses on. This view is coming to you from 2,700 meters under the ocean at the Seacliff hydrothermal vent fields, part of the Gorda Ridge Marine Trench. This is a place on the Earth's surface where the Pacific and Gorda tectonic plates meet each other and create a whole range of geological phenomena.
Sample done.
Sample ended.
Runner.
These voices you can hear are coming to you from the control
If you
van
hold it while you're doing all this, you save time.
of the exploration vessel Nautilus. We're operating about 180 kilometers off the west coast of North America.
Our end flow count is 19,713. Rate of 2.11 liters per minute and 12 liters per volume. Okay,
12.6.
thanks. 12.6, got it, 12.6.
You just don't need to go out to the hundredths place. You don't need to go to the hundredths place, but you should do the decimal. Because that's like 600 bills. You should also try, when you read flow counts, do it single digit by digit. Because you say 19, someone might mistake for 90 or 1550 or something like that. So now you're on 3. And I think I want to stay at the same position, but we're going to decrease the temperature bounds. so we can collect higher temperature.
Okay.
I,
So I'm frozen here for however long you want.
Yep.
what do you
Thank
want
you.
to ground it to then?
Let's do 90. That's low bound. And 115 is upper.
Okay.
Start it when you're ready.
So starting sample
You gotta quit that.
now.
No, you gotta quit it first and then start.
Now. 1745.
If it stays under 90 for too long, we'll just shift it down into the orifice.
Okay.
What's the weather looking like outside there? 20 knots. Current at 0.8. Okay.
So Eric, these fluid samples that we're taking, do these get analyzed on board, or are these all going back to Woods Hole?
They get analyzed for some properties on board. We do some pH measurements, conductivity, ORP, oxidation reduction potential,
Uh-huh.
and dissolved oxygen on board. But we bring a subset of that back for trace metal concentrations, as well as nutrient concentrations, see what kind of trace metal and nutrients are output into these the surrounding waters. And that's going back to University of Texas, Rio Grande Valley.
Okay. And a couple of questions on Nautilus Live just asking about the earlier microbial filtering we were doing. Although those scientists have left the van for, I guess, some much needed sleep, they've been working through the night.
It was higher earlier, but it dropped.
When they try to culture these bacteria, they will culture them in a warm environment, a controlled warm environment, sort of like a mini incubation oven. Typically, though, they won't try and bring them back to the same pressure that they were at depth.
Jess, can you reposition?
Sure. How would you like it?
Down into the orifice, like an inch.
Okay. Would you like me to rotate a little bit the wrist so that
Yeah,
that the nozzle is a little bit more pointed into the flow?
sure.
Roger.
.30°,
It's dropping.
20. 22°, 40°, 71, 85, 90,
90s.
100.
I'm frozen here.
Okay.
119, 130.
Let's go a little higher.
A little higher? Roger. Whoops. Is that too high for you?
Hold up for a second.
Roger.
120, 116, 111.
It's coming back down.
Yeah.
Eric, do you mind if I make a quick adjustment?
To
I can rotate again and just kind of overcompensate for this bungee and then freeze it down so that the angle stays a bit better if you'd like.
I think we're getting good temperatures right now.
Okay, I'll hold here.
So another great question on Nautilus Live, one which I don't know the answer to, but I was talking earlier about the cycle of water at these hydrothermal vents where seawater percolates down through cracks in the Earth's crust, comes into the vicinity of hot rocks, is heated, and then rises buoyantly back to the surface in these focused flows through the chimneys. I don't actually know how long that cycle takes to go from seawater at the surface to coming back as superheated water at the vents. It's a great question, though. One could think about it by trying to estimate the volume flow per second of water coming out of this vent, and then you'd have to assume, well, what kind of length of pipe is not the right word to think about, but what kind of underground channel has we got in terms of volume of material down to the place where the water is reacting with the rock, and then the ratio of those two volumes, the flow rate and the sort of the column of water that has to come up from below would tell you something about how long that must be taking.
You weren't on.
Oh, sorry. It's a little hot. Can we move it up a little bit?
Roger.
Okay, we're in better shape now.
Is that too? Yeah, let me know how that settles out for you.
We're in the 90s, in the low 100s.
Just another quick question on Nautilus Live about how do the microorganisms that we sample here at depth handle the change in pressure when they're brought back up to the surface. It's my understanding from conversations with the scientists, Amy and Sarah, that actually doesn't seem to perturb them very much at all. They're able to take those samples at surface pressure and incubate them to essentially grow colonies of microbes that they can then perform more detailed measurements on.
Just we need to whip down a little bit. It's 70 degrees.
Roger. Roger, moving down.
Back
That's
in the
hold
90s.
here.
That's good.
Fluctuating, it's in the 70s again.
Did you want a little bit more over the vent?
Yeah, maybe a little more into it.
Roger.
All right, we're in the 90s again and in the hundreds. And dropping again in 70s.
Josh, can we get the bubble cam on that wand if it reaches?
Oh.
Looks like you've gone through the other side.
Yeah.
Let's angle it downward a little bit.
Roger.
We're in the 50s, 40s, 30s. We're dropping. Stabilized in the 30s. Dropping. We're increasing. Not quite enough though. All right, we're in the 90s. And back in the 70s. We're in the never mind. Just fluctuating a lot.
Hold that right there.
Holding.
So just to follow on from that comment about the journey the microbes have to make from the seafloor to the surface and how they cope seemingly fairly well with it, once the scientists on board have actually incubated and grown more of those samples, they'll then even freeze them for their journey all the way back to their home base, which I think for Amy and Sarah is Woods Hole Oceanographic Institute on the East Coast.
It's 130 degrees. Can we move it a little bit up?
A little up.
It's down again.
Roger. Coming up. Sorry. Maybe too far. I'm frozen here.
Okay.
That looks good.
So as you can see, we're continuing to sample hydrothermal vent fluid at the Seacliff hydrothermal vent field. For those of you asking on Nautilus Live, this dive will continue through the day. I think we are intending to be operating at depth down up to about 5:30 this afternoon, Pacific time. Then we will be recovering the vehicles back on deck, hopefully at about 8 o'clock this evening, Pacific time, before we then start to pack up and make our return to our base in this area, which is in Vallejo in the San Francisco Bay area. We will then be prepping the ship for turnaround. One crew will be leaving, another group of scientists will be coming on board, ready to start next week on a mapping expedition from San Francisco to Hawaii.
It's everywhere.
So just to give you a sense of the different views you've got on Nautilus Live, if you happen to be watching in the quad view right now, on the top left you can see Hercules' view as we have a wonderful zoomed in view of this hydrothermal vent sampling. Top right you've got the Argus view that's been particularly clear and nice today, that shows Hercules just resting on the sea floor in the proximity of these hydrothermal vents. Quad view bottom left you can see a zoom in on the flow rate meter for the sampling device we're using. That's spinning around rapidly at the moment. That shows that we're pumping vent fluids to their receptacles on board Hercules.
Sample ended.
And then in the bottom right view of the quad view, you have a map that shows our location of the Nautilus. At the moment, about 180 kilometers off the west coast of North America.
End flow count is 27011. Flow rate 3.47. Volume 20.8.
Copy.
So is that 20 liters, Michelle?
Yes.
That's a lot of fluid. Does it still smell of hydrogen sulfide when you process it in the evening?
Oh yeah.
Eau de vent.
It's a fragrance line in
Yeah.
Macy's.
Oh yeah.
Do your hands smell like hydrogen sulfide?
No.
I don't think so. I wear gloves. Okay, where do you want to move now, Eric?
Where do we want to move? Let's get a background blank sample. Cool it off a little bit.
Okay.
Let's move to the. Let's move to the right, out of the flow.
Roger, right and up or just horizontal right?
Just horizontal right.
Roger, understood, horizontal right.
SCF just off comms briefly.
Is right here good for you, Eric?
What's the temperature?
It's still in the 30s, 20s. It's dropping though.
We'll hold it there for a second.
Okay.
It's in the teens.
I think it's just some
And-
stuff wafting in the area.
Yeah. Is
Oh.
that good?
That'll do.
Okay.
Sorry, there's not a really good zoom on the tip on this one though.
It's all right.
You want me to bound it? 0.
0 to 115 is fine.
Okay. Alrighty. Starting sample now.
The seat is comfier than I remember.
The bounds?
0 to
0 to
115.
Yes. What's our exact depth here?
Our depth currently is 2736.6 meters.
Thank you.
Did we see any cool biology this morning? Besides make-believe cats.
Yeah, there's
cats.
quite a bit at the other site that we were at.
Yeah, we're pointing out
Quite a bit of cats.
No, biology.
pointing out the worms and microbe. Well, we weren't pointing out the microbes, but you're talking about them.
Talking about them.
Be a
Lots of
lot
limpets, lots of worms.
Cool.
tiny bio. Would you call it microbio?
I just like the, oh, excuse me. I like the thought of some larger organism that's kind of peeking around the corner somewhere, out of distance, out of sight, just watching us. In like a nice way, not in a menacing way, of course.
like
I can zoom out on Argus and see.
like the boogeyman of the sea.
No, not like the boogeyman, just like a
Kraken?
curious little
Critter.
creature. Just being like, ooh, there's a lot of light.
Maybe a
Can't
little-
see anymore.
A little prawn or something.
We've had a lot of, like one little fish almost every dive between Herc and Argus.
Yeah.
Just
Yeah.
watching.
Yeah.
We had what we guessed might have been the vampire squid yesterday between
Oh,
Argus and Herc as well.
that's right, yeah.
Vampire squid? Is that the official?
That's a real thing, yeah.
Yeah. Huh.
Yeah.
Yeah.
They're really cool.
Do they suck on things?
I
Never hung
They
around
just
to
kinda
find
look
out.
spooky.
I'm just curious why
They look
named
pointy.
it the vampire.
I don't know.
Oh, they've got big folds of flesh between their legs that give it this kind of cape-like appearance.
Oh, okay. Well, why not name it like Superman octopus or something? Superman squid.
You just have to find a new one and
Yeah.
name it.
The caped octopus.
could work.
$115 left.
Roger.
So just to address that quick question on Nautilus Live, that folks were interested about the flow rate up from these vents and the flow rate down into from the sea into the subfloor. Basically, you have to have a continuity of flow. So for all the water that's coming out of the vents, you have to have water going back in through the seafloor via some source. And so essentially that continuous flowing around allows you to kind of maybe estimate the amount of time it takes to cycle from the seafloor back up to the surface again. I'm afraid my brain's not up to it at the moment, but come back to me in the afternoon after I've had a nap with a piece of paper and I might be able to do it for you. So Nicole, I saw you in the back row there. Are you handling watch lead and data logger at the moment?
Yeah, I'm covering 2 stations back here where Megan wasn't feeling well, so I
Okay.
hope she's feeling better soon.
Sure.
Michelle, the next one we're going to do bound from probably 10 to 115. We do it higher above the vent flow.
Okay. Sample ended.
So Jess, we're going to move it up and to the left into the vent flow.
Up and to the left into vent flow. Roger. And how far up would you like it?
Let's do 7.2 inches.
Just to make it fun.
Yeah.
I see.
So our end flow count was 34403. Flow rate 3.52. Volume 21.1.
Copy.
Somewhere around here good for you, Eric?
A little more left. Let's hold it there and see what we can get.
Roger.
What's the temperature at?